Calculations using subscript summation notation. First example, consider a vector A prime generated by rotating vector A through an angle theta in the counterclockwise direction. Prove that A prime dot A prime is A dot A, part A using matrix notation and part B using subscript summation notation. Now, how do we represent a dot product using matrix notation? So if I have a vector A dotted with itself, this is going to be represented by vector A in matrix representation transpose multiplied by itself. We know how this works. If you have three components, A1, A2, and A3, that's the transpose of the column representation, and this is the row representation. Row and column multiplied gives us A1 square plus A2 square plus A3 square. The scalar that we're looking for, that's the dot product of the two vectors. And similarly for A prime dot A prime, I have A prime matrix representation transpose multiplied with A. And how do I obtain A prime vector? I have to rotate the A vector by an angle theta in the counterclockwise direction, and that rotation matrix we have discussed in the previous lectures is cosine phi minus sine phi. So here it's not phi, it's theta, so it's cosine theta minus sine theta, sine theta, cosine theta. So if I have two components, A1 and A2, let's say this is a vector on the xy plane. And then a prime transpose will be, I take the transpose of this equation, which changes the locations, the positions of those two matrices, and then I take their transpose, A transpose and rotation matrix transpose. Okay, so A prime dot A prime can be written as the A prime transpose, which is this. So it's A transpose rotation matrix transpose multiplied by the so this is going to be A prime also, multiplied by the A prime, which is R of theta matrix multiplied by the A matrix. So this is going to be R theta multiplied by the A matrix. So we need to find out what is R theta transpose multiplied with itself. Cosine theta, it was cosine theta minus sine theta. This now is going to become cosine theta minus sine theta in the first column. And then I had sine theta cosine theta, so that's going to be my second column in the transpose. Sine theta cosine theta. If I don't take the transpose, then I have cosine theta minus sine theta and sine theta cosine theta. So let's do the multiplication. We have cosine square theta plus sine square theta, which is 1, minus cosine sine plus sine cosine, that is 0, minus sine cosine plus cosine sine, 0, minus sine, sine square plus cosine square, that's 1. So this gives me the unity matrix 1, the identity matrix. So A prime dot A prime I have shown to be A transpose multiplied by this matrix, which is the unity matrix, identity matrix I have shown here, multiplied by matrix A. And because the unity matrix multiplied by A is itself, so it's A transpose multiplied by A, which is nothing but the matrix representation of the dot product of A with itself. So A prime dot A prime is equal to A dot A. We have shown it using the matrix representation. Okay, now let's try subscript summation notation. What is A dot A? It is AI AJ delta IJ or AI AI. A prime dot A prime is AR prime AS prime delta RS or AR prime AR prime. Okay. Now, what is AI prime? It is obtained by multiplying the rotation matrix ij element with aj and summing over j. So it's rij aj. And what is a prime dot a prime then? The first term here is transposed, remember. So that's going to be AU R UR, and then I have AV, RRV multiplied by AV. So the first term is transposed, the second term is not transposed, so it's going to be AU RUR RRV AV. So RRU is the matrix itself, the rotation matrix representation, and RUR is its transpose. So that's when we change the columns and rows. So RUR AU multiplied with RRV AB. Okay, so if I write these AU and AB together, AU AB, RUR RRV and RUR RRV, this is summed over the index R, actually gives me the unity matrix, which is telling me that delta UV is what I will obtain. So this is actually in matrix representation R matrix transpose multiplied with R, which gives me the unity matrix. So in terms of the subscript summation notation, that means this is delta UV. Then I obtain A prime dot A prime to be equal to AU AV delta UV, which means it's AU AU, which means it is the dot product of A with itself. Okay, so in this example, we have shown that if a matrix A prime is obtained by rotating a vector A through an angle theta in the counterclockwise direction, using both matrix notation and subscript summation notation, their dot products are equal. So the matrix representation for the dot product of A with itself is A matrix transpose multiplied with A, and A prime with A prime is A prime matrix transpose multiplied by A prime. A prime matrix is obtained by multiplying the A matrix with the rotation transformation matrix cosine theta minus sine theta cosine theta. And A prime transpose matrix will be the transpose of this equation, A transpose rotation matrix transpose. So remember, in the subscript summation notation, I said AU is RU RAR, for example. But if I take the transpose, this is going to not have an effect on A. It will just turn into a column, row matrix. But the positions of the subscripts will switch in the rotation matrix for the subscript summation notation. So that's what I do later on. Okay, so A prime dot A prime is A prime transpose this multiplied with this. So A prime A transpose R R transpose times A, we have calculated explicitly, is the unity matrix 1. So identity matrix multiplied with A gives us actually A itself. So A transpose multiplied by A is nothing but the dot product of A with itself. So we have proven this result using matrix representation. Using subscript summation notation, the dot product is AIAJ delta IJ for the unprimed one, for the primed one, AR prime, AS prime, delta RS. And for AI prime, this is obtained by multiplying the A matrix with the rotation matrix. So it's RIJAJ. That gives us the ith component of the primed vector, and that's a summation over J. And A prime dot A prime, now I have to take the transpose of this, which means it will switch the positions. So it's going to be R U R A U instead of R R U A U. And now for this one, I have R R V A V. That's the vector itself. So RRU is the rotation matrix. RRUR has the rotation matrix transpose. AUAV and multiplication of RUR and RRV. RUR gives us, in matrix representation, we have seen the unity matrix, which means it's delta UV. So AUAV delta UV is AUAU, which is the dot product of A vector with itself.